Hello everyone, welcome back to my channel. So guys, in my previous video I talked about the vascular changes in acute inflammation. So before I talk about the cellular events in acute inflammation, let's talk about the chemical mediators of inflammation. Okay guys, don't forget that inflammation is a complex process of vascular and cellular alterations that occurs in the body in response to injury. Although injury brings about inflammatory response, released chemicals mediate it. So by this statement, I mean that when there is an injury, the body initiates an inflammatory response. However, it is not just the injury itself that causes inflammation. Rather, it is the chemicals released by the body as a response to the injury that mediates or regulates the inflammatory process. So, chemical mediators are substances released in response to stimuli like injury, infection, or stress to initiate and regulate inflammatory reactions. So, the work or job of chemical mediators is simple: to initiate and regulate inflammatory reactions. So that's what they do: initiate and regulate inflammatory reactions. Okay, so what are the sources of chemical mediators? The chemical mediators can originate either from cells, example mast cells, macrophages, platelets, epithelial cells, and so on, or from plasma. So chemical mediators can originate either from cells or from plasma. We know what plasma is. Plasma is the liquid portion of the blood. These chemical mediators can be released through processes like degranulation. Degranulation simply means the release of granules containing mediators, and these mediators can also be released through other processes like synthesis and secretion. So mediators can be released through processes like degranulation, synthesis, and secretion. So once released, they can act locally or travel through the bloodstream to exert their effects on target cells and tissues. So remember I said that the chemical mediators can originate either from cells or from plasma. So we have the cell-derived mediators or the plasma-derived mediators. So the cell-derived mediators are either already formed, that's preformed, or are synthesized newly in response to stimulus, whereas the plasma-derived mediators are present in inactive or precursor forms that must be activated to acquire their biological properties. So having known this, let's talk about the cell-derived chemical mediators. Remember I said that the cell-derived chemical mediators can either be preformed or newly synthesized in response to the stimulus. So under the cell-derived chemical mediators, we have the preformed and the newly synthesized. So under the preformed, we have the vasoactive amines. Example of vasoactive amines, we have histamine. Histamine is widely distributed in tissues and is stored mainly in the granules of mast cells, but also in circulating basophils and platelets. So the next example of vasoactive amines is the 5-hydroxytryptamine, also known as the serotonin. Serotonin is present in the mast cells of rats and mouse only. Next, under the preformed is the lysosomal enzymes, which are released by neutrophils and macrophages. and that's it for the preformed. So under the newly synthesized, we have prostaglandins, leukotrienes, platelet activating factor, activated oxygen species, and nitric oxide. Okay, now let's look at the plasma derived chemical mediators. In this group, we have the factor XII or Hagman factor, also known as Hagman factor activation group, and then we have the complement activation group. So under the factor XII activation, we have a kinase system, example the bradykinin, coagulation system, fibrinolysis system, and that is for the factor XII activation group. The next group, complement activation group. So under this one, we have the C3A, C5A, and C3B. So just like I said before, the plasma-derived chemical mediators are present in inactive or precursor forms that must be activated in order to acquire their biological properties. So now let's look at the actions of the chemical mediators, how the chemical mediators act. Okay, so substances like prostaglandins, nitric oxide, when released, cause vasodilation. Vasodilation is when the blood vessels get wider, and this will result or lead to increase in the flow of blood to a particular part of the body. Okay, substances like histamine, 5-hydroxytryptamine, also known as serotonin, C3A and C5A, bradykinin, leukotrienes, platelet activating factor can cause increased vascular permeability. Increased vascular permeability is when the capillaries become more porous than usual, allowing more fluids, proteins to pass through it easily. So these substances can cause increased vascular permeability. C5A, leukotriene, bacterial products, chemokines can cause chemotaxis, leukocyte activation. Interleukin-1, interleukin-6, tumor necrosis factor, prostaglandins cause fever. Pain is caused by prostaglandins, bradykinin. Tissue damage by neutrophil and macrophage lysosomal enzymes. So some of these mediators have more than one action. Let's take for example the prostaglandins. Prostaglandins cause vasodilation, they also cause fever, and they also cause pain. Another example is the bradykinin. The bradykinin cause increased vascular permeability. They also cause pain. Okay guys, so that's it for today's video guys, and I forgot to mention that tissue damage is also caused by oxygen metabolites and nitric oxide, and I mentioned neutrophil and macrophage lysosomal enzymes. Then we also have the oxygen metabolites and nitric oxide. So that's it for today guys. I said it before, saying it again, that's it for today guys. In my next video, I'll be talking about the cellular events during acute inflammation. So make sure to ring the bell icon so you don't miss my next video. And don't forget to subscribe, like, and share this video. I also like to know what you think about this video in the comment section below. Thank you.